So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic light waves. So guys, this video will be about reflection and refraction of light. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, a swimming pool is 2.1 meters deep. If it contains water of refractive index 1.3, calculate the apparent depth of the pool. So guys, let's go ahead and solve these out together. So we know that refractive index is equal to real depth over apparent depth. So in this case, the real depth here is 2.1, and then the refractive index is given as 1.3, but we don't have the apparent depth, so we make this the subject of this equation, where the apparent depth becomes real depth over refractive index. So that will be 2.1 over 1.3. So if we divide this, we'll have 1.6. So the answer to this question is option B here, 1.6 meters. And that's it for this question. So let's go ahead and consider the next question, guys. So the next question here is question number 2. It says, an object is placed 20 cm in front of a converging lens of focal length 15 cm. Calculate its image distance. So guys, we have the object distance here and we have the focal length here, and we are looking for the image distance. So guys, if we use the formula 1 over L is equal to 1 over U plus 1 over V, and then since we are looking for the V, we make it the subject of this equation, where 1 over V is equal to 1 over L minus 1 over U. So when we do that, 1 over L is actually 1 over 15, then minus 1 over U is actually 1 over 20, and guys, if we look for the LCM of the two in order to subtract here, 20 and 15 will have an LCM of 300. So 300 over 15 is 20, and then that minus 300 over 20 is 15, and that's 20 minus 15 is 5. So we have 5 over 300 here. So 1 over V is equal to 5 over 300. So in that case, 1 over V is equal to 1 over 60. So if we want to find V now becomes 60 over 1, which is 60. So the answer to this question, guys, is option C, 60.0 cm. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 3. It says, which of the following statements about light traveling from one material medium to another is not correct? We have A, it bends away from the normal if the speed is lower in the first material. B, its wavelength does not change. C, the refracted angle is less than the incident angle if the speed is higher in the first material. And then D, its frequency changes. So guys, the odd option here is option D here, which says its frequency changes. So guys, the frequency does not change as materials travel from one material medium to another, or as light travels from one medium to another. So the frequency does not change, and option D is the answer to this question. So let's go ahead and consider the next question, guys. So that's question number 4 here. It says, an object is placed on the principal axis and at the center of curvature of a concave mirror. The image of the object formed by the mirror is A, at the center of curvature, B, real and diminished, C, at the principal focus, D, real, inverted, and magnified. So guys, the answer to this question is option A here. The image that will be formed by the mirror will be at the center of curvature. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 5. It says, images formed by a convex mirror are always A, inverted, B, real, C, behind the mirror, D, magnified. So guys, the answer to this question is option C. Images formed by a convex mirror are always behind the mirror. And that's it for this question. Let's go ahead and consider the next question. So that's question number 6 here. It says, the phenomenon which occurs when light changes direction as it passes from one medium to another is called A, reflection, B, interference, C, refraction, and D, polarization. So guys, the answer to this question is option C, and that's refraction. So when light travels from one medium to another medium of different densities, they actually change direction, and that phenomenon is known as refraction. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 7. It says, which of the following pieces of apparatus is the radius of curvature equal to twice the focal length? We have A, parabolic mirror, B, diverging lenses, C, dicot lens, and D, converging lens. So guys, the answer to this question is option D, converging lens. So the radius of curvature of a converging lens is twice the focal length. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here, question number 8, says, two plane mirrors are inclined at an angle 20 degrees to each other. Calculate the number of images formed when an object is placed between them. So guys, we're going to use the formula n is equal to 360 over theta, all minus 1. So guys, where theta is 20 degrees here, and we're going to solve that n is equal to 360 over 20, all minus 1. So guys, 360 over 20 is equal to 18, and 18 minus 1 is 17. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 9. It says, the angle of incidence of a ray of light on a plane mirror is 55 degrees. Determine the angle between the reflected ray and the mirror. So guys, the answer to this question will be same as the incident ray, because on a plane mirror, the angle of incidence is also equal to the reflected angle. So if the angle of incidence here is 55 degrees, that means also the reflected angle is 55 degrees. And that's option D here. So option D is the answer to this question. Let's go ahead and consider the next question, guys. So the next and last question here is question number 10. It says, a concave mirror forms a magnified and erect image only when the object is placed A, beyond the radius of curvature, B, at the center of curvature, C, at the focus, D, between the focus and the pole of the mirror. So guys, the answer to this question is option D here. A concave mirror forms a magnified and erect image only when the object is placed between the principal focus and the pole of the mirror. And that's it for this question. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. Finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.